This is the second video on transformers, and here we're going to look at the transformer calculations. Before we can do that, we need to identify the quantities that we're dealing with. So this is the primary, this is the secondary. On the primary, we have the primary voltage. There is a primary current, and this side of the transformer has a certain number of turns, a number of windings, and we use the letter N to represent the number of turns. So this is the turns on the primary. We then have exactly the same scenario on the secondary. So the secondary has a number of turns. The current leaves the secondary and goes to supply whatever the circuit or load is, and there is a secondary voltage. Okay, so those are the terms we're going to use. Before I say anything else, something quite obvious occurs here. The voltage from input to output is totally dependent on the turns ratio of the transformer. We'll look at that in just a second. But basically your output EMF, the secondary voltage, is directly proportional to the number of turns on the primary and the secondary. Let's just summarize these quantities into a formula. So we had voltage, we had turns, and we had current. So primary voltage over secondary voltage equals primary turns over secondary turns. And the last bit, this changes. This is secondary current over primary current. So this formula, there's a space for it on your handout, very important. We will only ever use two quantities at a time. We're not going to use all three. We will use, for example, voltage and turns, or turns and current, or voltage and current. So we only have 4 quantities in play at any one time. You won't use all 6 at once. So the first phase I want to look at is solving these using ratios. Let's have a simple look at this example here, the transformer I've coloured in green. Let's suppose we have 2000 turns on the primary and we have 200 turns on the secondary. We can find a ratio that covers how these turns work. If you take the smaller number and divide it into the bigger number, 200 into 2000 goes 10 times. 200 into 200 goes once. We have a ratio of 10 to 1. So hopefully that is fairly obvious for you. Let me give you a quick example. So if the primary voltage was 230 volts, so there is Vp, then the secondary voltage is going to be 230 divided by 10. 23 volts. I hope that makes sense. So that is a straightforward ratio. Won't always be as comfortable as 10 to 1. And this is a step down transformer where the output voltage, the secondary voltage, is smaller than the input. It could be the other way around, that we're doing a step up transformer. So that was about voltage and turns. Let us have a look at current. So we need to remember with current that the ratio works in the opposite way. Here we can see Vp over Vs, Np over Ns, Is over Ip. So the current works in the opposite way. Let me give you a quick example. Let's suppose that on this particular transformer we had a ratio of 10 to 1. So let's talk about voltage. If this is 30 volts, then this is going to be 23 volts. However, when we discuss current, the opposite happens. Remember, this formula is the opposite way around for current. So if I had 1 ampere there, then where the voltage steps down, the current will step up. So the secondary current goes the other way. Okay, let me do another example of that one. Let us suppose that on this transformer we have a ratio of 20:1. In other words, this side is 20 times bigger than this one in terms of terms and probably in terms of voltage too. But if I gave you a current on the secondary, let's say this is 5 amps, then the primary current is going to be 20 times smaller. So the primary current is 0.25 amps. Okay, I'll let you think about that one. Let's move on to part 2 of this particular section, transformer calculations. The first part was all about ratios. We're now going to use the full formula, and you're going to need to remember how to transpose. So in this first example here, we're going to use this formula. Sorry, let me go back. Vp over Vs, Np over Ns, current swaps, Is over Ip. That's important that you remember that, and these are the formulae we're going to use. So let's have a look at some reminders on transposition. Let's get the right colour. So if I had Is over Ip and Np over Ns. So let's assume we had a question which was involving currents and turns. So this is the formula you may write down. You may want to write Np over Ns equals Is over Ip. The order isn't critical. So this is what we have, and let's suppose I want to make Is the subject. So the secondary current is what I'm trying to find. So ask yourself, is the secondary current on the top line? Yes, it is, so leave it there. And what that means is all we have to move is this. We need to move this to the other side, and it goes diagonally up to there. So my next line is going to read Is equals Np over Ns, and that Ip goes up there. Hopefully that makes sense for you. At this point, if you have numbers for the primary turns, primary current and secondary turns, you can put them in and work out the answer. So that's a quick reminder on that transposition. Let me deal with a different transposition. So here I have current and turns again, and in this one let me make Ip the subject. That is what we want to find. So coming over here, Ip is on the bottom. That is no use. The thing you want to find must be on the top line. So your first move is to move it from the bottom left to the top right. It's going to go up there. So our next line is going to show Is equals Np over Ns, and Ip goes up to join Np. So we still haven't found what we want. This is what we want, but it's now on the top line. So I now need to move this to the other side and this to the other side. If it's on the top on the right, it's going to move to the bottom on the left. And if it's on the bottom on the right, it's going to move to the top on the left. So my next line here is going to be IS NS over NP equals IP. So this is fine, this is correct. However, we would normally write the subject on the left and the remainder of the equation over on the right. So we would normally write IP equals IS NS over NP, subject on the left, the remainder of the equation on the right. So at this point, you're ready to put some numbers in, and then you can solve the problem. So this was reminders about transposition. And before I move on to the final page, you're only ever going to use a combination of two of these. So let's move on to the last bit. So there is a place on your handout to record these. Let's have a look at them right now. So on example 1, the question is written out in words as it would be typically. Extract the important information. The primary current is 2 amps. The secondary current is 6 amps. The secondary turns is 500. We have to find the primary turns. Okay, so your formula is going to involve N and I. So let me start then. N over N equals I over I. So NP over NS is IS over IP. We now need to transpose that. So is there a transposition required to find NP? No, because NP, the thing we want, is right at the top waiting for us. So all we have to do is move that up there. Let's do that. NP equals IS over IP, and that NS sits up there. Let's put the numbers in that we have over here. So that is 6 times 500 over 2, and that comes to 1500. Okay, I hope that one makes sense. Let's have a look at example 2. So on example 2, the question reads to give you the following information. The turns on the primary is 306, turns on the secondary is 50, the primary voltage is 110. What is the secondary voltage? So something on those lines. So if we start with our formula, we have turns and voltage. So N over N equals V over V. And it's NP over NS is VP over VS. We need to transpose this to make VS the subject. VS is on the bottom, so we need to move it to the top. So moving that up there will give us VS times NP over NS, and that equals VP. Still haven't found VS, we've got it on the top line. We now need to move these two. This will go down, that will go up. So that will give us VS equals VP NS over NP. At this point you can put your numbers in. 110 times 50 over 306, and that comes to 18 volts. Hope that lot makes sense. Have a go at the questions on the handout.